Greetings, children! Last time we left off, we were talking about probability, and we were talking about independent probabilities. So we're talking about just doing a single event, like rolling a die. So, this time we're talking about if it's a little bit more complicated than just rolling a single die, just tossing out a die, right? So, what we're talking about is when we are trying to find the probability of multiple events that occur one after another that are still independent events. So, we talked a little bit about this last time, and then we're going to talk a little bit more about it this time, as far as we'll actually see the math behind it. So, when you roll a die, it has the same probability no matter how many times you roll it. If you roll a die, and it's just a regular six-sided die, if you roll a die and you're trying to roll a 2, you have a 1 out of 6 chance of rolling that 2. If you pick it up and roll it again, you still have a 1 out of 6 chance of rolling a 2. So if you roll it a third time, you have a 1 out of 6 chance of rolling a 2. Then if you pick it up a fifth time, I know we skipped 4, but a fourth time, and a fifth time, and a sixth time, and a seventh time, and an eighth time, it's always going to have that same probability. As long as there's a 2 on the die, and it's a regular six-sided die, you'll have a 1 out of 6 chance of rolling a 2. So the probability is the same every time you pick it up and re-roll it, because it's an independent event. Now, most of the time, we don't just look at a single independent event or multiple independent events and just say, oh, well, it's always 1 out of 6. That is true. However, people usually ask more complicated questions like, how was the probability of me rolling 4 2s in a row? Now, that's a completely different question. So each time, each independent event, so each one has a 1 out of 6 chance. So if we're talking about it 4 times, it's a 1 out of 6 chance of rolling a 2. So there's 1 out of 6 for the first roll, 1 out of 6 for the second, 1 out of 6 for the third, 1 out of 6 for the fourth. Now, when you're doing that, it gets more complicated because now you're saying, well, what's the probability that we roll only 2s 4 times in a row? Well, you would have 1 out of 6 times 1 out of 6 times 1 out of 6. So it becomes 1 times 1 times 1 times 1 over 6 to the 4th, or 1 over 1,296. So the probability of rolling a 2 4 times in a row is a much different question. So it turns out that to find those other more complicated events, what we do is we take each independent event, which was just rolling a die, and we multiply them. The way we find the probability of each independent event is the same as we talked about before. The number of favorable outcomes, there's 1, 2, out of the number of possible outcomes, 6. So, for example, if we were talking about a typewriter, and I think there was an example in your book that says there's a monkey sitting at a typewriter and they get to push 3 characters, and it's all capital letters. We just have the letters of the alphabet. And let's see what the question says. It says, suppose a monkey types at a typewriter with only the 26 capital letters on the keyboard and types one letter. What's the probability that they'll type the letter M? Since they're monkey, I guess. So that would just be 1 out of 26. So now it's going to ask, like, what's the probability that they would type car? Which is, there's only one C, so 1 out of 26. There's only one A, so 1 out of 26. And there's only one R, 1 out of 26. And we would multiply all 3 of those. So we would have 1 over 26 cubed. So when we multiply the top, 1, bottom, 26 cubed, which is 26 times 26 times 26. So our final answer will be 1 out of 17,576. So you can see it's a pretty small probability that if they got to pick 3 random letters, some monkey just sitting there at the keyboard typing away, that it would be CAR. Okay? So when you have independent events, you multiply them. So let's say you're flipping a coin. What's the chance you'll flip heads? 1 out of 2, right? What's the chance that you'll flip heads 50 times in a row? That's a lot different. I once had a student that told me that he flipped a coin before school that day, and he flipped heads 98 times in a row, which would be 2 raised to the 98th power, which my calculator can barely even do. It says that the answer is 3.169 times 10 to the 29th. So we just recently went over scientific notation, so you know that that is actually a really huge number, because you'd have to move that decimal over 29 times. So shout out to my former student, you know who you are, for telling fibs about flipping a coin heads 98 times in a row. Shame on you. Anyway, whenever you're doing this, make sure that you're trying to figure out the number of favorable outcomes over the number of possible outcomes for each one. The top doesn't always have to be 1. I know the examples we just looked at, it was 1. But the top does not have to be 1 on these. I think most of the ones in your book, it actually is 1. Let's take a look at example 6.13c. It says, what's the probability that a monkey will type mathematics on a typewriter? So it would have to be 26 to the 11th, which is 1 over, let's see, that's 100,000, million, billion, trillion, quadrillion. So it'll be 1 over 3 quadrillion, 670 trillion, 344 billion, 486 million, 987,776. Plus, it'd probably be a pretty smart monkey if it typed mathematics, I'm just saying. Because any monkey that knows mathematics, I mean, pretty smart. All right, so take a look at example 6 in the problem solving. It's talking about the probability that you'll pick a code out of randomly chosen digits. So let's think about how many digits we actually have, right? In our decimal system, the word decimal has the keyword deci, which is 10. So we have 10 different digits. So consider that we have 10 digits, 0 through 9. So we have 10 different digits. Now, when it's talking about a 2-digit number, it could be a 0 first. So think of it like a combination lock. So I just wanted to make that clarification for when you're doing your homework. 0 is a possible answer for your first one. Normally, when we talk about 2-digit numbers, we're talking about ones that start with 1. Right? 1, 0, 10 will be our first one. But here, since we're talking about like a combination lock, 0, 4 is a possibility. Okay? So that means that there'll be 10 for each. So if you're choosing a random 2-digit number and you're using all 10 digits, that means you have 1 out of 10 for the first number, 1 out of 10 for the second number. So that would mean that you have 1 out of 100 for any specific number. So like if we were trying to figure out how many ways is there for us to choose 32, or how many ways is there for us to choose 04 or 91. So it would be 1 out of 10 for the first digit, 1 out of 10 for the next digit. All right, so remember, it's still independent probabilities, each event, but then you multiply the events to find the total probability. Thanks. Have a great day.